section, what I'll cover is variables and data types. So in the next lecture, you will be able to create and understand variables. And in the lectures after that, you're going to learn about the various data types that we use in Python. So in this video, I just wanted to introduce you to this new section, and let's go to the next video where I explain variables. See you. Hi, in this lecture, you're going to learn about variables. So what is a variable? Well, a variable is like a container where you can store various data types in Python. For instance, this program now, this doesn't have any variable in it for now. So let me try and execute it. And you'll see that this prints out the hello string. String is a data type, but we'll cover that later. Now, what is a variable? Well, variables will keep your code more organized. Let me create a variable here, greeting. So you can call your variables whatever you like. You can give them any name. However, there are some naming rules which I'll mention in just a bit. So let me create this variable for now. I'll store in this variable, I said variables are like containers, so I'll store this text in the variable greeting. And then what I do is, instead of doing print hello, I'll do print greeting. And save the script, Ctrl S, and then go to the command line, the upper arrow key, enter to execute, and you get the same output. So this is how you create a variable. You don't use any quotes, because when you use quotes, you are creating a string data type, not a variable. And you can also use a dash before the variable. That would also be fine. So you get the output correctly, but you cannot use numbers before the variable. So Ctrl S to save, execute, and you get an invalid syntax. So this syntax is not valid in Python. But you can use numbers after or between the variable name. Let's say here greeting2. So that would be fine to use. So that's the condition about naming your variables. You can start them with a letter or an underscore. Now, if you're not experienced with programming, you may still be confused on why do we use these variables. Well, this is a very simple program, actually very useless, but normally your programs will interact with users. That is what we call a real program. You create a program to give it to people so they can interact with the program, they can generate all different outputs and so on. So let's go ahead and make this program more dynamic. So what I'll do here is I'll get the text from the user interactively. To do that, you need to use the input function. This is also a Python function. Inside the function, you can enter a message to the user. So let's say write a greeting, a colon, and make some space there, and then you print greeting2. Yeah, save the script, execute, and now the program is asking us to enter some input. So let's go ahead and say hi this time, and we get the output printed out in here. Hi. So what happened here is we created a variable, and that variable will store the value that the user submits in the command line here in the terminal. So the user submitted the hi text, and this text will be stored in this variable. So as I said, variables are like containers. And then you can use this text in various ways. But in this scenario, I'm just passing it to the print function, so I want to print it out on the terminal here. And the print function will get the value that is stored in the greeting2 variable and will print it out on the terminal. That's it. And yeah, I'd like to close this lecture now, and I'll see you in the next lecture. Great. Now let's learn numbers. Let me open an interactive shell here to explain this faster. And so numbers, you know what numbers are. To create a number, you just type the number in Python, and that's it. And you also have operators, like this is the plus operator. And you can also store numbers in variables. Let's say a equals to 2, b equals to 3, and then if you do a plus b, you get 5. Something to note is that, if you do that in here, a equals to 2, b equals to 3, and then if you just do a plus b, and then you execute the script. Let me open another terminal. You'll not get any output in there. The reason is that you are not printing out anything in your program. So this is different from an interactive session. Here, if you simply do an operation, or if you simply call a variable like that, you'll get the output promptly. So this is just for simplicity when you're trying things out, so you don't have to pass print explicitly, but Python will understand that you meant print. But here things are more strict, so if you want to print out the output, you want to say print a plus b, and then execute, and you get the output. And yeah, basically that's the only difference between executing a program from a Python file and running the code in the interactive shell. So these are numbers, and I can prove that if I do type 2, for instance, you'll see that this is an int type, which means is an integer. So basically we have integers and we have floats. These are the two main types of numbers. A float is, let's say 2.4, it's a float, and I can prove that. 2.4, type 2.4, you'll see that this is a float. However, if you do type 2 in brackets, you'll see that this is a string, it's not a number. Therefore, you cannot make operations using a string and a number. So Python will give you a type error, and this is saying cannot convert integer to string implicitly. So when you do a string plus something else, Python expects that you were adding another string after a plus sign, so that's why it says I cannot convert integer object, so you cannot convert this to a string implicitly. Because if you were to do 2 plus 3, you'd get 23, because Python treats these two as text. So to understand it better, let's add some text here, b, so you get 2a 3b. So it's a concatenation operation. When the plus operator is used with strings, it is referred to as concatenation. Now let's go back to our sample program that we used earlier, which was this one in here. So now what if instead of getting a greeting from the user, you ask them for their age? Enter your age. So this is just a message, you can write anything you want there, but just try to have a message that makes some sense to the user. And so also I'm going to change the variable name to something more meaningful, age, and then what I want to do is, let's say new age, I want to calculate their age plus 50. Why not? And then print out the new age. Save the script, and let's go and execute this. We are going to get an error here, I warn you, but it's good that you see the errors that we get, because that's how you learn better. And so Python, my program, execute. For now it's working fine, because what happens is Python executes a script line by line. So it goes to the first line, and if there is no error, it executes that line. And in this case we have an input function, so the program is on standby mode, so it expects from the user to enter the input. And so let's enter the input here, let's say 20 8, and here's the error that we get. So again, you saw this error before. This is saying type error cannot convert int object to string implicitly, and you also have the line here that the error occurred. So these are important messages, and line 2 in here. So what's happening is that age is a string, it's not a number. Therefore, Python cannot add up a string with a number. And so why is age a string? Because that's what the input function produces. So the input function gets the user input and converts it to a string. So even if you pass a number there, this will always convert everything to a string. Therefore, Python, cannot concatenate 28 plus 50. So what can you do in that case? Well, you want to convert that string into an integer, and for that you want to use the int function. So it's a Python function that does the work. As you can see, it outputs now the correct output. So 28 plus 50 equals to 78. And similarly, you can convert numbers to strings. Let's say str50, and I think we'll get an error here. Yep, it says type error, unsupported operand type for plus. So you're adding up an integer with a string. So integer with a string. If you like to convert this to a float, let me remove that. Save, execute, 28, you get 78.0. Because what Python does when you use float is, float 28, it converts it to 28.0. So floats can be useful in certain scenario, and you'll have a lot of scenario in the course. So don't worry about that now, because we have real world applications later on where you see the real benefit of everything that we are explaining here in these early sections that cover the basics. So this is about numbers. Try to practice them a little bit, and I'll talk to you in the next lecture. Hi again, in this lecture I'll show you how to do math operations with numbers. So we're going to look at math operators. Let's go straight away and open a Python session, and let me write a math expression there. 20 minus 10 divided by 5 times 3 in the power of 2. And what we get is 2.0. So why did I write this long expression? Well, because I want to explain to you the order of operators. So when you have multiple operators in an expression, the one to be executed first is the exponent. So we have 3 in power of 2 here, and that will give us 9. So power is the first to be executed, and after that is division and multiplication. Actually, division and multiplication are on the same level when talking about order, but the one that is first will be executed first. So in this case, division is the first one. So what will happen here is Python will ignore minus for now, so it will divide 10 by 5 and it will give 2, and then it will do 2 times 9. So again, 10 divided by 5, 2 times 9, 19. And then we have the rest of the operators, which could be a plus or minus. So in this case we have minus, and so 20 minus 18, we have 2.0. And so you'd ask why we have 2.0, because 10 divided by 5 gives 2.0. So division outputs a float in Python 3. If you are on Python 2, it would output an integer. Now, to make your expressions look better, you'd want to remove the spaces for the power operator, and also you do like that. So now you can read it better. So 2 times 9, and then 20 minus 18, and so on. You get the idea. You get 2.0 again. And now if you want to execute the minus operator first, you'd want to put that inside brackets. So why did we get 18? Well, because 20 minus 10 gives 10, and then 10 divided by 5 gives 2, and then 2 times 9 gives 18. That's the idea. And then you could also do this, put these in brackets, and what would happen here is, 10 here, 15 here, in the power of 2, so 15 in the power of 2, and then 10, so 10 divided by 15 in the power of 2. Let's see what we get. Yeah, we got that, so let's see if I was right. 15 in the power of 2, we get 225, and then we got 10 on the other side, so 10 divided by 225, we get that number. So whenever you want to change the order of operators, you should use brackets. So yeah, I hope you get the idea, and please try this out. So try to do a few operations with numbers to get used to it. And yeah, I'll talk to you later. Thanks. Hi, welcome again. In the previous lecture we were talking about numbers. Specifically, we looked at integers and float data types. So these are referred to as data types in Python. So integers and floats. In this lecture we're going to look at strings. I already mentioned strings in the previous lecture. So a string is everything that goes inside quotes. Hi there, that is a string. And of course strings can be stored in variables. And you can print those variables. So we're using the interactive shell now, but of course you can use a Python script as we did previously. So numbers were used to do math operations, but strings are used for displaying information for the user. So let's say you have a web application and you want to generate some text dynamically on the web page. So you would use Python on the backend, and Python would send strings to the HTML code, and HTML would render the code on the web page. Basically, that's the idea. Or if you want to create a notepad, an editor with Python, such as Atom, let's say, all these things you see here, so my program.py, selection, find, all these would be written as strings inside Python. And then you display them on the interface using various functions. For instance, if you want to display a string on the terminal, you'd use the print function. Now strings have methods associated with them. What I mean with methods is, let me go ahead and try out a method. For methods you need to use a dot notation. So you refer to the string, which is string C in our case, actually variable C, but the variable is holding the strings, so it's the same as doing here dot. So let's do C dot replace, and what I want to replace is E with I. So I'm replacing, for string here, I'm replacing letter E with letter I. And what that will do, it will replace all the letters, all the occurrences of this letter in the string. So you would ask, where can we see these methods? Well, that's very easy actually. You can do dir and then pass a string there, any string. It could be C, it could be an empty string or whatever, and that will print out all the available methods that you can use with strings. So let's say C.upper, that will convert the string to uppercase letters. Now if you want to know what these methods are about, you could ask for help. Just do help, and then C, so the string, or just empty string dot replace, just like that. And here you get the help. And so you get the definition here, replace method of the string instance. So string is like the blueprint that creates strings objects. Or you can say the data type that represents text. Look here is the syntax. So what you do is you use the string like we did. So let's say here replace, then you open brackets, here is the old item you want to remove from the string, and then the new item we want to replace it with I, and then what you see here in square brackets, that means this parameter is optional, so you can either pass it or not. In the previous case we didn't pass it, so what Python did was it replaced all the occurrences of the E item. But if you want to replace only the first occurrence, you do 1 there, and that will replace only the first E with I. That's how it works. So strings, they support functions, so print is a function here, and they support methods like this one here, and they also support operators. So you can do here plus there, and you get here there. Or you can make it more readable like that. So an empty space is also a string. And yeah, that's about strings for now, and I'll talk to you later. Hi again. In the previous lecture we talked about strings, and in this lecture again we are going deeper into learning strings. Specifically we're going to look at indexing. Indexing is a very important concept, not only with strings but with other data types that we'll be looking at later, such as lists and tuples and dictionaries. So please follow this lecture. And yeah, let's talk about indexing. Let me open a Python interactive session. And let me create a string. Hi there, exclamation mark, and close quotes. Now, when you create a string, every string that you create, Python under the hood, what it does is it assigns a number to each of the items of your string. So it starts from 0, so age will be assigned an index of 0, and then a 1 for I, 2 for the Y space, 3 for T, 4, 5, 6, 7, 8. So the exclamation mark character will have an index of 8. So you would ask, why is this useful? Well, this allows you to extract certain parts from a string. And there is a certain notation to do that. You'd want to access the string, so in this case that's the variable C holding the string. And then you want to use square brackets. So an opening square bracket and then a closing square bracket, and inside those square brackets you pass the index of the item that you want to extract. Let's say I want the T character, so that would be 0, 1, 2, 3. I pass number 3 there as an index, and that will extract for me letter T, which is actually a string. So you can check the type of the output, and you'll see that that's a string. So a string is made of strings, you can say so. If you wanted age, you'd pass 0, and if you wanted the last character, well, you might have to count, so 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I'm including type there, sorry about that. So C8 would give you the exclamation mark. But there's also another indexing system there that Python uses. So in this case we had to count from the beginning to the end of the string, but wouldn't it be useful if you had another system that lets you count from the end, so from right to left. Well, such a system exists and it starts from -1, so the exclamation mark would be -1. And yeah, that you can extract that with that. -2 would be E, R would be -3, and so on up to age. So you have two indexing systems there, which allow you to extract items depending on whether the items are in the beginning or near the end. Now, what if you want to extract more than one item from a string? Let's say you want to extract high. Well, there is a notation for that too. And so high is expanding from index 0 to index 1. So up to here. So let's try 0 to 1. That will not work very good, but let's see. So as I said, this will return only age. So it doesn't return item with index 1. And that's because splitting in Python, so we're splitting a string here. Splitting in Python is upper bound exclusive, which means that the upper bound of the split here is not included in the output. So if you want to include I, you'd want to pass the index after I, which is 2. So this is a string just for reference, and so we extracted item with index 0 and item with index 1, and then the split starts right there at index 2, so it doesn't include the space, just high. If you pass 3 there, that would include the white space as well. And similarly you can pass like 1, and that will include I and the space. There are also shortcuts, so if you pass 0 to, like nothing to 3, that is the same as doing 0 to 3. So it will include 0, 1 and 2. And similarly, if you want to extract there with the exclamation mark, well, what you'd want to do is T would have an index of 0, 1, 2, 3, so 3, and then you can just pass a colon there and execute it, and that will give you there with the exclamation mark. And let's now try to extract R and E using negative indexing. So something to know is that even though we are using negative indexing, which starts from right to left, the splitting will work from left to right, which means the first index you want to pass is that of the first item. So R, we pass -3 for R, because you know we have -1, -2 and -3. So -3 for R, and then we want E, which is -2, but since splitting is upper bound exclusive, we want to pass -1 there. So let's try that, -1, execute, and yeah, we get the correct output. That's the idea. If you didn't pass anything here, you'd get the exclamation mark as well. So it will take a while until you get used to this, but with some practice you'll be able to remember these notations. And yeah, that's what I wanted to cover in this lecture. So this was about string indexing and splitting. So you split using the index that Python uses on the background. Yeah, I hope you enjoy this, and I'll talk to you later. Thanks. Great, now let's look at lists. So in the previous lecture we were looking at strings and indexing and splitting strings, and now we'll be working with lists, which are very similar to strings. They are similar because they are both referred to as sequences, so they are sequences of items. The difference is that, let me open Python. So the difference is that a string is made of other strings, so it can contain only strings, so characters or strings, whatever you like to call it. However, lists can contain various other data types, let's say age, a letter, a number, and also a string. So this is a string, the first one. This is a number, an integer. This is also a string with multiple characters. And that is a list. So for lists, you want to use square brackets to create a list. Execute. And yeah, you can call it. And so this is a list of 3 items. And you can also store other objects in a list, but we'll cover other objects in later sections. You know, we have table objects with lots of data. You may store files in a list. You may store widgets of graphical user interface that you are building, and so on. So lists are very useful. And lists also have indexing, and you can split lists, you can extract items, and so on. So the good news is that lists have the same indexing system as strings. So you learned that in the previous lecture, and you can go ahead and apply that system now. So let's extract number 2. That would have an index of 1. Execute that, and yeah, you get 2 there. If you check the type, you'll see that's an integer. So every item of a list has its own data type. You can also access more than one item of a list. Let's say you want the first 2 items. You do 0, 1, 2. So like that, or 0 to 2, whatever you like. And that will produce another list. So the type of this split is a list. The type of the split of a string is a string. So S for the string here, C for the list. Lists now have methods associated with them, just like strings do, and so you can check what methods you have available there by just doing dir list. So list is the blueprint. You can use list, you can pass empty square brackets in there. It's the same thing. And then you can use help to look at each of these methods. So these are the methods without the underscore. And let's look at the append method. So to apply a method, you do C, the dot notation, append, and here I'll add 3. Well, what that does is it adds another item to the end of the list. So it appends an item to the list. And you can explore the other methods if you like. So let's say help, remove, like that. And you'll see how to use that remove method. So you do C remove, and then you pass the value of the item that you want to remove. So not the index, but the value. Let's say we want to remove 2, and you see that 2 is now gone from the list. So yeah, look at the other methods of the list and try to experiment with lists and play around with them, access items and split them, and you'll be good to go then. Yeah, thanks. I'll talk to you later. Let's now look at tuples. In the previous lecture we looked at lists, and tuples are very similar to lists. The only difference is that tuples are not mutable, so you cannot change a tuple. Lists are used much more than tuples, so tuples are only used in very specific scenario. We will see some scenarios throughout the course when we build the real-world applications. So you don't have to worry about understanding when to use a tuple in programming for now. Anyway, I want to show you the syntax. So you can create a tuple like that. So a tuple, just like lists, they may contain different data types. Let's say 3, 4, and so on. Oh, sorry, I was writing in the terminal. Let me open the Python shell. So again, you have strings, numbers, and floats, if you like. Whatever type that you want, you can pass in a tuple and in a list. And of course, you can use indexing for tuples as well. So let's access the last item, and that will give 4.6. The difference is that, tuples, they have some slight different methods than lists. So if you do dir list, you'll see that lists have much more methods available than tuples. So for instance, you can append items to a list, you can clear the list and copy and count. Count is available for tuples because count doesn't change the data type, so it doesn't change the tuple, it just counts how many items are there in a tuple. As I said, tuples are immutable, so you cannot change them. That's why these methods that change the data type, like inserting new values and popping out values, removing values, reversing and sorting, so these are not available. And yeah, this is more or less about tuples. In case you need them later, they are there for you. Hope you're enjoying the course, and I'll talk to you later. Hey, hello! Let's look at dictionaries in this lecture. This far we looked at strings, we looked at lists and tuples, and so now we have yet another data type, and these are dictionaries. Let me open the Python shell, and let me create a list first. I'm just creating this for a reference, so to compare lists with dictionaries, but you don't need to create a list for creating a dictionary. So to create a dictionary, you need curly brackets. So an open and a closing curly bracket. And then inside that, you'd pass the items of the dictionary. Now the difference here with dictionaries is that instead of letting Python add default indexes for your items, you want to create those indexes yourself, explicitly. So therefore, for dictionaries, you do something like this. Name, a colon, and then the item. Let me write another one. Surname, colon, and then the other item. And yeah, that's it. That's a dictionary. So what we have here is, when I was talking about indexing, I was referring to these things. Actually, these two are referred to as keys, not indexes. So for dictionaries, you can create custom indexes, so to say. And so these are keys. So we have key and value. Key and value. This is good because now if you want to access one of the values of the dictionary, again you'd use square brackets, just as you did with strings, lists and tuples, and then there you pass the key, which value you want to extract. So if you want to extract John, you want to pass the key of John, and that will extract the John value. Something to note is that dictionaries are an ordered collection of items, so sometimes you may notice that the order of the key and values is not maintained. So you may see that surname has gone the first place, so surname Smith, the pair has gone the first one, and name John is the second one, and so on. So this is different from lists and strings and tuples. And the reason Python doesn't keep the order is that, the way you access dictionaries is you explicitly pass the key of the dictionary when you access it, and so you don't need to know the order of the dictionary. Whenever you want to access something, you say surname, for instance, and that will return Smith, no matter where Smith is, so whether it is the first one, second one, or and so on. And interestingly, in dictionaries you can also pass you can have like lists as values, or even tuples. So let me write a tuple there, or let me keep it like that, and let me add another key and pair here. Let's say cities. Let's say John Smith lived in 3 cities: Porto and San Diego and Bali. You close a bracket there. So as you see, we have the key here, we have the colon, and then you have the value, which can be anything. So it can be a string, it can be a number, it can be a list, a tuple. In this case, that's a tuple. So if you access now cities like that, you'd get, sorry, I had two brackets there, so you would get the tuple. And then you can also do tricks like, you know, if you want to access Bali, you'd add other brackets there and pass 2, and that will return Bali. So why is that? That's because, you know, up to here you have a tuple. That's a tuple object, and then from that tuple you use again the square brackets notation to access an item from that tuple. So you want item with index 2, and that is Bali. And yeah, that's about dictionaries. Try them out some more, play around, and you will be able to comfortably create and access items from a dictionary. So hope you're enjoying this, and talk to you later. Hey, welcome to this new lecture. This is the most important lecture you have had so far in this course. So please try to make the most of it. And this is actually a new video that I'm adding to the course. I didn't have this lecture a few times ago, so I added this quite a while after I published the course. And until now I had explained this concept, so the errors, little by little in other lectures, but I felt that that was not enough, and I was seeing that students were still having difficulties in understanding and dealing with errors in Python, so I decided to make a dedicated lecture for errors in Python. So here we are, and I said this is the most important lecture because, you know, we learn about functions and strings and numbers until now in the previous videos, and these are individual concepts that, you know, you'll learn now or later. You'll learn functions and strings and etc. But if you don't know how to read an error, how to understand an error and deal with it, if you don't know that, you will have troubles dealing with every other object like functions and strings and numbers, etc. So understanding an error and knowing how to deal with it, how to fix it, is very important. And even the most experienced programmers, they make errors in their programs. The difference is that they know how to read these errors, how to understand them and fix them. But everyone makes errors. So if an error shows in your program, don't panic, just follow the instructions that I'll give you in this video on how to fix the error. So that's what this lecture is about. So what is an error anyway? An error in a program is a bug that causes the program to function incorrectly. Now in Python we have basically two types of errors. We have syntax errors and we have exceptions. Let's first focus on syntax errors and let's forget about exceptions. We'll go to exceptions after we explain syntax errors. I have this code here, and actually this is a Python file. This is the icon showing on a Mac. So currently I am on a Mac computer, but that doesn't make the slightest difference. No matter where you are, Linux, Windows or Mac, everything is the same. So I have a terminal here, and let me go ahead and execute this program. This has a few errors, so let me show them. On Mac you can call Python 3 with the Python 3 command. On Windows you can just call Python or whatever command you are using. You can also use any editor that you like. And so errors.py is the name I gave to the script. Execute. So this is now an example of a syntax error, and this is the entire body of the error message, and this is very important. So whenever you get an error, the first advice I give you is don't panic. Just focus on the error, read it line by line, just like you're reading a poem or whatever. So the first line of the error points you to the name of the file that has the error. In this case is errors.py. Then you have a comma, and after the comma you have the line where the error occurred. So it's line 3, and you can see here that line 3 is this one here, but you also have, for your convenience, Python prints out the line in the terminal. So int9, here is where the error is, and just after that you have
the type of the error. So it's a syntax error. You also have other types of errors, such as name error, type error, but those are exceptions, and I'll explain later why we call them exceptions. So this is one type of error, a syntax error, and the others are exceptions. So this is a type, and then you have a description after the colon. Sometimes the description is more specific, more detailed. This time is just invalid syntax. So you have to figure out where you did some error, where you missed some syntax of your program. And you also have this arrow here pointing upwards. And the arrow points you either at the token that the error is occurring, or at the end of the token. So a token is, this is a token in this case 9. So it can be a number, it can be a string, anything. So at this point, this is pointing at the token. But it could also be like that. 999. Save the script. Execute. In this case, you see that it's pointing you at the end of the token. So around here you have an error now. And I know that int is actually a function. And functions in Python, they need to have brackets. So you need to pass 999 inside brackets, like that. And delete that. Save. And execute again. Alright. You've got another error, but don't panic again. This is my advice always. Instead read the error, it says file errors.py, the file, line 5. Oh, line 5 this time. So it's not line 3 anymore, which means that line 3 was fixed. So what Python is doing is it's going through all the lines one by one from top to bottom. It checks the first line, it says, oh, it's fine. No error there, goes to the next line, no error. Goes to the third line, no error this time. Fourth line is also fine. And fifth line has an error. So again, it's a syntax error. And this one is more specifically described. So missing parentheses in call to print. Note that you'll get this error only if you are on Python 3. If you are on Python 2, this won't be an error because in Python 2, print was a statement and was not a function. So with statements like return or print in Python 2, you didn't have to pass brackets. This syntax would be correct. So again, this arrow here is pointing you at the token. So we just add brackets there. Ctrl S to save the script and execute again. This time we don't get any error, so the script executed fine and printed out the output here. 1, 2, 3. So we had 3 print functions printing out output. This doesn't return any output because we're not printing anything. So this just gets the function input and produces some output, but that doesn't print anything. If you want to print it, you want to pass the print statement function there. There could also be other types of syntax errors, and such as you want to define a list 1, 2, and 3, but instead of closing it with a square bracket, you use a round bracket instead, like that. Save the script and execute. And you see that you got a syntax error, invalid syntax, at line 5, which is this one in here. Again, the arrow points you at the token, so you need to figure out how to fix this round bracket here. And you know that you need to close it with a square bracket, so that should fix the issue. So that's about syntax errors. They are very easy to fix. In the next lecture, I'll explain exceptions. So see you there. Hi again and welcome to this new lecture. In the previous lecture, we talked about errors in general, and I focused on syntax errors, which is one of the 2 types of errors you have in Python. So you have syntax errors and you have exceptions. Now we're going to talk about exceptions in Python. So every other type of error that is not a syntax error is an exception. And often all errors, syntax errors and exceptions, they are referred to as errors. So you're going to hear this all over the place. Now I have a new script here that I created for this lecture. Try to guess what I'm going to get as output when I execute this script. So I have a equals to 1, b equals to character 2, print int 2.5, and print a plus b. So guess what I'm going to get for a moment. Okay, now let me run the script, Python 3, errors.py. File errors.py, line 4, which is the last line. This one, we get a syntax error, invalid syntax. Now this can be very confusing for you now, because you're looking at the print a plus b expression, but you don't see any error there. So for a beginner this can be quite frustrating, but try to look back on the left of the arrow here. So think of the arrow, that the arrow is pointing at the token, and the token has not been written correctly in the script. So in this case, the problem here is that this line here, it has an open bracket, a round bracket, and then it has the int function, and then the int function has its own brackets that is wrapping inside its input. So these are the brackets of the int function, but the print function doesn't have a closing bracket. What I did is that instead of putting a bracket there, I actually wrote another print function. So Python was expecting a closing round bracket, but I typed in a print function. That's why this is saying that this print function is not in the correct position. That's the idea. So always when you see this arrow, first look at this line, but then look before that also. Sorry about this. So always when you see this arrow here, first look at this line here, but also don't forget that the problem might also be before this line. Okay, so that was about the syntax error. I'll explain why I talked about this syntax error here. Let me execute this again. So the syntax error was fixed now, but we still have another error. So the reason I included a syntax error in my code was to show you that Python actually first checks for syntax errors. So basically it parses the code, it looks for syntax errors, it doesn't execute the code yet. So when I executed Python 3 errors.py in here, the code was not executed, but the interpreter just checks for syntax errors. It doesn't check for exceptions just yet. So first you need to fix the syntax errors, and that's what we did here. We added this bracket and we fixed the syntax errors. Now Python is throwing out an exception. And here is where I executed the code. And see the next line, we have number 2 there, which is coming from the output of this line here. So from line 3, we got the output correctly. So basically, again, Python executes the script from top to bottom if it doesn't find syntax errors. If it finds syntax errors, it doesn't execute anything. So 2 is printed out, and then you get this trace back of the error, which starts there and ends in here. That's the block of the error. Sometimes the errors may have more than one type of error. So in this case we have only one type of error, which is a type error, but you may have multiple blocks here. However, the most important error that you must focus on is the last line of the error, so the last block of the error. In this case we have only one block, so we're focused on in that. And line 4, which is this one in here. This is the line. Again, the line is printing out just like in the case of syntax error. And here you have the type of the error here, which is a type error. So what's a type error? A type error means that there is something wrong with one of your object types in your script. and you have the description here, unsupported operand type for plus. So this is trying to say that the plus operator has an unsupported type, so the plus operator, in other words, doesn't support one of the types that you have given to it. So it either the type of variable A or the type of variable B. So it says int and string. So it doesn't specifically say that whether int or string is the object, but it says that you cannot use a plus operator with an integer and a string. And that's logically wrong, because you cannot add a number to some text. That's what Python doesn't understand, and it throws a type error. So exceptions are like logical errors, and you need to use your logic now to fix the error. And you use your logic by carefully inspecting the error, and that's what we did. So what we want to do, you want to fix this. Now it's up to me whether I meant to concatenate these two objects or do a mathematical addition operation. So let's say if I was intending to do an addition between these two numbers, then I would have to convert b to a float or an integer. Save that, execute, and yeah, in this case you don't get any error. You get 2 printed out from the third line, and 3.0 from the last line that we have just fixed. However, if my intention was to actually print out the concatenation between these two strings, instead of converting b to a float, I would have to convert a to a string. In this case, I would get the text 1 and 2. 1 and 2. So that would be a string object, not a number. Even though here it shows as a number, it's just how the terminal prints it out. So again, these are errors that occur in runtime, so when the script executes. Syntax errors are parsing errors, so the interpreter tries to understand whether the script is syntactically correct, whether you have followed the Python syntax rules. So you need a bracket, a closing bracket for opening bracket, you need a closing quote after the opening quote, and so on. Now there are also other types of exceptions, not only type error. You may have a name error. Let's say here, instead of printing out that, we print out C. Save, execute. And here is a traceback. Again, 2 was printed out from the third line. And the traceback says line 4 at print C. Name error, name C is not defined. So again, this is not a syntax error because you haven't made any mistakes with the syntax. You have this variable name, which is correct. You have brackets opening around brackets and closing around bracket. So everything is syntactically correct, but this C object, Python doesn't know this. You haven't defined this C variable, so Python doesn't know what to print out. Python is able to print out A because it knows that A refers to the 1 to integer 1, and so it prints out integer 1, but C doesn't have anything, so you get this name error. And whenever you get a name error, you know that this name here has not been defined by you. So to fix this, you may want to define C like that and execute, and you don't get any error. You may also have other types of errors, such as C divided by 0. See what you get. A zero division error, division by 0. That's the description of this error. So division by 0 is not mathematically possible or meaningful. And since Python is based on mathematics, then it throws an error. You need to fix that. You need to remove that expression that divides by 0. And yeah, that's about errors in Python. I hope you understood a great deal of this lecture and the previous lecture as well. So it's relatively easy to fix errors. However, sometimes there are errors that you might have difficulties understanding and fixing them. So later, for example, we're going to work on libraries, and sometimes libraries, they have different kinds of errors. However, nothing to worry about, because there are other things that you can do for an error that you don't understand. And I'll talk about that in the next lecture. So I'll see you there. See you. Great, welcome again to this new video. This is the third video about errors. So we talked about syntax errors, we talked about exceptions, and now we're going to talk about how to fix an error when you don't understand the message. So let's focus on this error. A zero division error. In case you were good in mathematics, you could easily fix this error. So you'll be able to understand that you cannot divide you cannot divide a number by 0. So you'd fix this by removing this expression here. However, if you are not that good in mathematics, you may find this difficult to understand. In that case, the fastest way to fix this error is by copying this line here, Ctrl-C. So select it, copy it with Ctrl-C, or right-click and copy there, and then go to Google. Just paste it. Now, on Google, this got around 100,000 results, so Python is very popular, and you'll get a solution for almost every problem that you'll get with Python. So before looking at documentation or asking a question somewhere, it's very likely that someone else has had your issue before, and they have asked a question about that, and there is a solution about that as well. And a very, very good question and answer website is stackoverflow.com. And almost always when you search for an error on Google, the first results will be from Stack Overflow. Someone has asked a question with this title. It says, I faced an error when I ran the program using Python. So it's the same exact error as you, like that. How to avoid that error. And it also talks about the desired output. And there are two answers for this question. The answer with this green mark here is the accepted answer, and it has the most upvotes. So 11, and this has 2 downvotes. So -2. Actually, the difference between upvotes and downvotes is in the favor of downvotes. So these are 2 different answers that you can look at. Usually you want to look at the accepted answer that has the solution. However, in this case, this also has the explanation. It says you cannot divide by 0. This causes Python to raise an error. That's still a good answer, and I think it didn't deserve to have this balance of votes. But this one gives a solution on how to handle an error, and that takes us to another concept, which is handling errors in Python. So let's say you have a program, you have a function that gets 2 input values, and then it divides those 2 input values. However, sometimes the user may pass 0 as a second input. And in that case, if you divide, let's say the first value would be 2 and the second value would be 0, your program would crash. And if you want, you can use exception handling to actually avoid that program from crashing. And you can do that with a try and except statement. Anyway, we'll cover that in the next lectures in this section. So this was about searching for an error on Google, and you can easily find the solution to that. As you see, these are very clear questions. It's a big community, and everyone can vote up and down and can comment. So basically, the answers are very accurate. However, you'll not always find an answer on Google. In that case, it's time to ask your own question. So the first thing is, again, you check if you understand the error and fix it if you understand it. The second thing is you do a search on Google, and if the first 2 fail to solve your problem, then it's time to ask a question. And you can ask a question either inside the course So you can, while watching a video, you can browse Q&A, which stands for question and answer, and you can do a quick search if you find an existing answer to your question here. And if you cannot find it, then you can ask a question, or you can ask a question on Stack Overflow. You can use this button here, ask question, and I'll be happy to help you here on the course interface Q&A section, or other people can also help you on Stack Overflow. However, something is very important to know. The structure of your question is very important on getting a good answer. Sometimes there are very bad questions, like, let's say, my code is not working, how do I fix this? And that's all. With that very little information, it's very hard to get a good answer. So it's very important to ask a good question, and I'll show you how to ask a good programming question in the next lecture. So that's a very important lecture as well. See you there. Hey, hi again, and welcome to yet another lecture. In this lecture, I'll show you how to ask a good programming question. As I mentioned in the previous lecture, asking a good programming question is very important to get a good answer. And let me first show you what's a bad programming question. For instance, I'm going to click on Ask Question, and here is the title of the question. A bad programming question would have a very generic title like that. Here is the body of the question where you have to describe your question in detail. Some people, they just say, I got an error when trying to numbers. And I just pause the question. A better question would be to include the error, the code there that you executed, like that. However, that is also not enough, because you also need to show the error message. So let me delete this, and a good programming question would be, when we're talking about questions that have an error, questions that talk about an error that you got in your code. So this is your code. A good title would be to include the error message. So that one would be a good fit. If it's a very long message, then you can choose to include only the name of the error without that. And then a good question would be, hi, I run the following code and expected to get division in the last print domain, but I got an error. Here is my code. So you put the code there, your entire script. Don't worry, if your question is long, it's better to be long than to be incomplete. And here is the error. And here, make sure to include your entire error traceback, including the output as well. So from this line of the command line up to the next line. So this entire thing goes to your question. Just copy it. Don't worry if it's long. Can you help? So that would be a good programming question. Now this is still missing something very important, and that is the highlighting of the code. You need to select the code and click on this icon here. The error as well. And let me pose the question. External links must provide free educational content. Just click on proceed. And here is the question and here is how it looks like on the other end. So this question has 4 good elements that make it a good question. The first element is that the poster is mentioning what he or she expected to get as output from the script that they were running. So it says that I was expecting to get the division in the last print statement, which is this one here, but I got an error. So the first thing is you need to include the expected output. You need to explain what you were expecting, because otherwise, if you don't explain what you were expecting, that the other person who wants to help you doesn't know the goal of your code or of your question, so it doesn't know how to help you to reach to that goal. So expected output is the first thing. The second thing is you need to include your entire code. And make sure that you include your code as text. It's better to use text as rather than screenshots, because text, the person who wants to help you can copy your code and run it on their Python interpreter. But if you include screenshots, they are images, and it's hard for other people to try out your code. If you ask this on Stack Overflow, your question would get closed, because if you ask it, oh, we're using a screenshot rather than the text version of your code, the question would get closed, because there are very strong rules in Stack Overflow to have a high quality question and answer site. So that's the second element. The third element is you need to include your entire screenshot, entire error traceback, sorry. So from the beginning up to the end. That was the third element. And the last element, the fourth element, is you need to highlight your code. Just like that. You see, this is much more visible and easier for others to troubleshoot. So the course interface has that function there that you can highlight your code. On Stack Overflow, you also have that capability. So just go to ask question, you write your code here and highlight it, and then use this curly brackets. Yeah, that's it. If you ask good questions, the odds are that you're going to get a good answer as well. So I hope this makes sense, and I hope I showed you something that you didn't know, and I'll talk to you later. See you. Hi again, let's have one more lecture about errors in Python, and this particular lecture will be about handling errors. Handling errors can be an advanced concept to digest for now, because you're still going through the basics of Python and you haven't seen any real application yet. But later we will use error handling when we're building real-world applications. So you're going to understand error handling better later on. For now, let's just focus on the syntax and try to understand as much as you can. I'll go and do an example here, which I mentioned earlier. Let's say we have a function that does division between two given numbers, like that. Return A divided by B. And then you call the function here, divide 1, 2. In this case, the function will try to divide 1 by 2. And let me print out the output so that we can see it on the terminal. Go to the terminal and execute the script, so you get 0.5. Now that's good. However, if the user enters, let's say, 0 there, like that, execute, and your program will crash, so it will show an error. Now this one here is an example of a longer error message that I mentioned previously in the previous videos, that you might have more than one error in your traceback. So for instance, this says file line 4. This line here. So that line is where Python captured the error at first. So basically Python was trying to execute this line, but it couldn't do it. It didn't manage to do it because this line was trying to get the information from this function. And this function was trying to do this mathematical operation using 0 after the division. So that is not possible, and Python is pointing that out here. So that's the main error in line 2 in this expression. So that's where you should focus. However, when you ask questions, you should include the entire error message in your question, as I mentioned previously. So back to handling errors now. What I'm trying to say here is that if you had other functions here and other lines of code, that you want to execute, that you want Python to execute. But if the user passed this 0 number here, the other lines would not be executed. So your program would crash, and you don't want that. And the way to avoid that is by using try and except. So basically you try to capture the exception, to handle the exception. And the way to do that is quite easy. Try, you say try and return AB. So this has to be indented like that. So try is indented because it's under the function definition. And then return is indented because it's under the try expression. Then you have except execute. So this has to be in the same indentation level with try. They are the same block. So except if there is an exception, what you want to do is print out you are dividing by 0, or is meaningless. So let me try this now. And you get 0 division is meaningless, and none. Oh, sorry, I meant to do here a return, not print. I explain you why you get none there. And so you got none as an output because what the function did was it tried to do this expression, but it got an error, so it ignores this line, it doesn't execute it, and then it goes to the next line. So this line is executed when this is not executed. And so it printed out 0 division is meaningless, but it also printed out none because when you execute a function that doesn't have a return statement, such as in this case, we had a print statement here, a print function, not a return statement. In that case, if the function is not returning anything, it can have a print function or other function as well. But if it doesn't have a return statement, then it will print out none. So basically, it executes the other procedures, such as the print statement, it prints out the statement, but if it doesn't have a return statement, it prints out none. Anyway, save this now, execute again, and in this case you get only this 0 division is meaningless printed out there. So basically, if you had other lines of code here, like that, those would be executed as well. And that happens by using the try and except block, which makes sure that the code flow continues. So, one other important thing to note is that it is advisable to actually here use the exact name of the error that you want to accept. So, 0 division error. And as you see, this got turned into blue. Which means that this is actually a Python keyword. It's recognized by Python. And in that case, if you execute this, you get the same output actually, like that. Or if you pass a number there that it is possible to get a division from, you'll get that. Sorry about the backslash. I typed that by mistake on my terminal. Execute again, so you get this. And so what I'm trying to say about the 0 division error is that, sometimes you might get other types of errors in your code, other types of exceptions. So let's say you have a name error there, and you are saying that accept all errors. When you don't pass this, you're basically including all types of errors there, and that is a bit dangerous for your code because you might have problems that you don't notice. And basically you are ignoring them, but you shouldn't. So it should be specific there, explicit, like that. If there are other types of errors, such as a name error, that name error will crash your program, so you know what's going on. And you need to be specific. If you want to handle that error too, then you can add another exception here, except name error for instance. Yeah, that's about handling errors in Python. I hope this makes sense. I hope I explained this well. And yeah, this is about errors. I'll talk to you in the next lectures. See you.
Hi and welcome to this new section. In this section, you're going to learn about two very important concepts in programming. These are functions and conditionals. So, functions are used to keep your code more organized. So think of functions as small chunks of code, which together build a program. That is what you need to know for now. Functions are useful for other things as well, but you'll understand it as you build the real-world programs. In the next video, I'll write a function, but that is just a standalone function, so it doesn't interact with other parts of the code. It's just a function. But when you see the large applications later on, you'll see how the function integrates with other parts of the code. So that's a good thing of creating real-world programs. That is how you learn how to do programming in real life. And that's about functions. And then in this section, you will also learn conditionals, which basically are used to have your program make decisions. So if that number is greater than that, do this. If it's not greater, then do this other thing. That's basically the idea, but you'll see it in action. So this is about the introduction of this section. I'll see you in the other lecture. Hi again, in this video you'll learn how to create a function in Python and how to use that function. So let me go ahead and create a script. Let me name this my function.py. And let's go ahead and create the function. Creating a function will always begin with the def keyword, which means define. And that is followed by the name of the function. So you need to give your function a name. Let me name this minutes to hours. And as you may guess already, what I'm creating is a function that will convert minutes to hours. So you create the procedure on how to convert minutes to hours, and then you can call that procedure. So you can call that function. You can give that function any values when you call it, and the function will produce an output depending on the value and depending on the formula, on the procedures that you write in here. So let's go ahead and do that. Minutes to hours. Now functions, normally they have some input and they produce some output. The input goes inside these brackets in here. In our case, the input could be minutes. So this is just a variable. You can give it any name that you want. You can give it any name that you want for the function name as well. So the input is minutes and then the output will be hours, but you don't write the output here. Here what to do, you always use a colon. Press enter and that will be auto indented. So as you see, the functions, everything that you write below the first line of the function definition is indented, and every line after that. So the def keyword, the name of the function, the input, and here we write the body of the function. What we want to do is, let's say variable hours equals to minutes divided by 60. That should give us the hours. Note that if you are on Python 2, you want to do 60.0, because if you do that, you'll get an integer as an output and not a float. So in Python 2, you have to explicitly pass a float when you do division to get a number, to get a float with decimal points. I'm in Python 3, so I don't need to put 60.0 there. And yeah, this is a simple function, so this is what the function will perform, and then the last line of the function is normally a return keyword. So notice that these are reserved keywords, def and return. And what I want to return is, well, guess what? The output, which is hours. So that's the idea. We are getting minutes. The user will input a value for that later when we call a function, and then minutes will be divided by 60, and that operation, that number will be stored in the hours variable, which is a variable that exists only inside the function. So this is called a local variable. If you call it outside the function, it will not work, but we'll cover that later. And so then we return the value of that variable. Now, I'll save this and open the terminal. Make some space there, and let me execute the script. You get nothing. The reason for that is because what you did here is you just defined a blueprint. You are not using that blueprint. So what you do next is you need to go ahead and use that blueprint. So which means you need to call that function. So backspace to go here to unindent. Unindenting means that you are done with the function definition. So when you start a new line, like here, that means you are not writing inside the function. And so to call a function, what you do is you just call the name of the function, minutes2hours, and then you open brackets, and then inside brackets you pass a value that you want to use as input. So let's say you want 70 minutes, you want to convert them to hours. Save the script, go and execute. Again, you will not get any output, but let's see. As I said, you won't get any output. So why is that? Well, that's because you didn't perform a print operation there. You didn't call a print function. So what you do is you do print, so open brackets, close brackets, and inside the brackets goes the function call. Save your script, go here, execute, and yeah, you get the hours. 70 minutes is equal to 1.1666 hours. So it's important to know that this value here, this is just a number. So you can see that by doing type and execute. Oh, sorry, I didn't print it out. And so this is a float number, so just a number. The function gets an input and it generates an output, which is defined by the hours variable. So whatever is stored in the hours variable, that is the value that the function will output. And yeah, you can do things like, you can use this output to do other operations. Let's say you want to add 10 hours there and you want to print that output, so expect this to be 11.1666, so on. And of course, now in your script you can add more functions if you like, like that, like seconds to hours. You pass seconds there, and here seconds, return hours, and so on. And of course this works separately, so you can say print seconds to hours and pass there. Actually we have to change this because this would be divided by 3600, and let's say this number of seconds. Execute, and you get 2.0 hours. And you also get the other output in here and this one here. Now, something important to know is that these are custom functions, and this one here is also a function, but this is a built-in function. So custom functions are functions created by you, and built-in functions are functions that are created by someone else. So in this case, print is created by Python authors, and print also has its own code, but it's more a low-level code, and it's actually written in C, so you won't be able to see the code for print. And yeah, this is an introduction to functions. In the next lecture, I'll show you some more advanced features of functions. So let's see you there. Alright, in the previous lecture I showed you the syntax of a function definition and the syntax of how to call a function. So this is the basic representation of a function. But there are some more things that you can add to a function. So that's what you're going to learn in this lecture. And I'll make this simple. I'll delete this. And here we are. And so here we have only one parameter. Still, this is called a function parameter. However, you can have more than one parameters for a function. Let's say seconds. So in this case, I allow the user to enter both minutes and seconds, and then the program will calculate the hours based on that. So basically we want to add seconds here, seconds divided by 3600. So yeah, I hope I'm fine with the math here. So minutes divided by 60 give you hours, and then seconds divided by the number of seconds in 1 hour gives you the hours. And yeah, we add them up and we return hours. Therefore, let me delete this 10 here. In this case, when you call that kind of function with two parameters, you'd want to pass two values, 60 let's say and 300 for seconds. Save, execute, and you get 1.25. And that's how you can add multiple parameters to your function and multiple values. Now if you don't pass a value there, one of the parameters, and you execute, you will get a type error. This is saying type error minutes to hours is missing one required positional argument, which is seconds. So you are not allowed to miss a value for a positional argument. So seconds is a positional argument which you need to pass in the function call. So these are referred to as arguments when you use them here, when you're talking about function call, and they are referred to as parameters when you pass them in the function definition. So parameters, and when you're talking about function call, you refer to them as arguments, and this is the value of the argument. And so positional arguments need to have a value passed in here. But default arguments don't need a value, and a default argument is when you use something like that. 70, and let's pass 300 in here. Execute. So syntax error, non-default argument follows default argument. The non-default argument here is this one. So positional arguments, such as seconds, are also referred to as non-default arguments. So the non-default argument second follows the default argument. That gives you a syntax error in Python, because Python will get confused when you pass this 300 here. So it doesn't know whether you pass it for this one or for this one here. Therefore, you need to pass the default argument after the non-default argument. So seconds and minutes. Now if you save the script and go here, this time you'll get a correct output, so 1.25. So let me summarize again what happened here. We have a non-default argument and a default argument which has a default value. Therefore, when you call the function and you pass only one value, Python knows that you're passing that value for the non-default argument. And for the default argument, Python will use the value of 70. However, if you pass another value there, let's say 200 minutes, save the script, execute, you'll get another output, because Python this time used the value of 200 for minutes instead of its default value. So when you don't pass a value, Python uses default value. When you pass it, Python uses what you passed in the function call. So this is useful when you create functions where some of the arguments will have a value that is not very likely to change very often. Something else about functions before I close this lecture. You don't always need a return keyword in here. You can also do, let's say, print hours, and then you don't need a print statement there. You just do that, execute, and you get the same output. However, note that, if you do +10 now and you execute, you'll get an error, because it says non-type and int So unsupported operand type for not type and integer, which means the not type is this one here. So this is not a number, and you can see that by doing print. So print the type of that function, of that output, and you'll see that this is a non-type. So the function doesn't produce a number when you use print. So bottom line is, when it comes to what the function does, you have two types of functions. You have functions that generate an output, and you have functions that perform some procedure. So this was an example of a function that performs some procedures. In this case, what this function did was it calculated hours and it printed hours. It didn't return an output. Other cases might be like, you know, when you create a file, so you process some files, you create a text file, you write some output in that text file, and you don't need a return keyword in that case. But we will see that later when we cover file handling in Python. Most of the time though, you will have to return a value here. So that's the idea. This is about this lecture, and I'll talk to you later. Hi, here is one more lecture about functions, and this one is in a more practical view, because what we're going to do is we're going to save that. We're going to look at the program that we built in the previous lecture. Sorry, in the previous section. So this simple program. Note that these are not the real life applications that this course covers. So these are just small snippets of code. Don't confuse this with the real life applications. We'll cover 10 real world applications later in the course. So in this program, what this did was it asks you for the age. Let me guess. That's not exactly my age, but anyway, 90. So this will print out your age plus 40. So 90 in this case. And what I want to do in this lecture is I want to organize this code better by putting this inside a function. So this will help you understand functions, how they are used in a more real life situation. So the function basically had three components, and that was the input, the body of the function, so the operations that the function performs, and then the output. So in this case, we are going to somehow get the input from this